All right, let's get started with example 2. So we're talking about coordinate proofs. We just took figures and we placed them in the coordinate plane. Now, once a figure is in the coordinate plane, what you can do is you can use the slope formula, right? Remember, m equals y2 minus y1 all over x2 minus x1. That's the slope formula. You can use the coordinates of the vertices. You can also use the distance formula, right? Remember, d equals the square root of x2 minus x1 squared plus the quantity y2 minus y1 squared. Or you could use the midpoint formula. The midpoint equals x1 plus x2 all over 2, y1 plus y2 over 2. So once that figure is in the coordinate plane, you can use any of these to prove statements about the figure. So let's look at example 2. Okay, so we are going to write a coordinate proof given rectangle ABCD with these vertices, and what we need to prove is that the diagonals bisect each other. Okay, so first I'm just going to plot my figure here. So this is 0, 0. This is A, 0, 0. Then we have B, which is 4, 0. This is B, 4, 0. Then we have C, which is 4, 10. And then D, which is 0, 10. Oh, that's not a 10. There's a 10. Okay, now we just make our figure. Okay, and then what we're trying to do is prove that these diagonals bisect each other. And that means they cut each other in half. So this side would be the same as this, and this would be the same as this, right? So for these to be bisected, what happens at the middle point of this diagonal? What is this? Oh, of this line, this is the midpoint of this line, right? And what's the middle point of this line? It's also the midpoint. So if they bisect each other, what would happen is that they would both be in the midpoints of each line, which means the midpoints of both of these lines would be the same. If the midpoints of this line and the midpoint of that line is the same, then you know that it is bisecting each line. All right, so the key to this problem is the midpoint formula, right? Which is, what is the midpoint formula? The midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay? So first we're going to find the midpoint of AC. So I'm going to go AC. All right. So the midpoint of AC, and I'm going to call this my x1, y1, oh, C, x2, y2, right? So it's going to be x1, 0 plus 4 divided by 2 and 0 plus 10 divided by 2. I simplify. 0 plus 4 is just 4. 0 plus 10 is 10. Keep simplifying. 4 divided by 2 is 2. 10 divided by 2 is 5. So that means the midpoint of AC is equal to 2, 5. Looks about right, right? Now, what we need to do is we need to find the midpoint of BD, okay? So let's go ahead and figure that out. So the midpoint of BD And I'm going to call this one my x1, y1, x2, y2 equals, it's going to be 4 plus 0 divided by 2, and 0 plus 10 divided by 2, right? That ends up being 4 divided by 2, 10 divided by 2, and we get the same thing. 4 divided by 2 is 2, 10 divided by 2 is 5. So that means the midpoint of BD I guess I need some lines here, is 2, 5. Now if we see, we can see that they are the same, and when they're the same, a lot of times they say coincide. They're right, the midpoints are right on top of each other. They're stacked on top of each other. They're coinciding. So what we're going to say is that the midpoints coincide. They're right on top of each other. They're the same. Therefore, the diagonals bisect each other. So since 2, 5 is the midpoint of this, that means this is the same as that. And since 2, 5 is the midpoint of this one, it means that they are the same as well. Okay? They cut each other in half. Perfect. Okay, let's look at the next example. Check it out, example 2. So you're going to have to switch. I kind of messed up. See how it's 3 below there, but that's just because I messed up. So, oh, where is my 2? We need the check it out example 2. Oh, here it is. It's on the next page, and it says check it out example 3, but check it out example 2 is right underneath it. So that's where you need to go. Okay? So check it out example 2 says, given right triangle ABC has vertices, A is 0, 6, right? B is 0, 0, and C is 4, 0. So it's saying this is a right triangle, okay, given that ABC has vertices here, here, and here. It says right triangle. So this is a right triangle, means that's 90 degrees, right? And D is the midpoint of AC. Okay, so D is the midpoint. Perfect. What we need to find is that the area of ADB is 1/2 the area of ABC. So ADB, this triangle right here, this is small, right? We need to prove that this is 1/2 the size of the big triangle. So we're finding that the area, I'm just going to write it, of triangle ADB is 1/2 the area, 1/2 times the area of triangle ABC. So that's what we have to determine, right? So to determine that, we have to figure out, well, what is the area of ABC? Okay? What's the area of it? And the area of triangle ABC, it's a triangle, so you got to just use the you're going to use 1/2 base times height. That's the area for a triangle. Now, what's the base? This is the base. So the base is 1, 2, 3, 4 units, right? Because we started here, it goes there. So B equals 4. And what's the height? This is the height here. So it goes all the way up to 6. So it's 6 units. So we stick it into our formula. And we get the area of triangle ABC is equal to 1/2 times, what's the base? 4 times the height, which is 6. And we can just simplify from here, right? So, you know, 4 times 6 is 24. And then the area of triangle ABC equals 1/2 of 24 is 12. So that is what the area of the big triangle is. So we need to prove that the little triangle is half of that, okay? So to do that, we need to figure out, so this triangle, we know what this vertex is, we know what this vertex is, but we don't know what this one is. So we need to determine what this is. Now, how can we figure out what this is? What did it say about D? D is the midpoint of AC. So if we find the midpoint of AC, we'll know what D is, right? Or actually, yeah, we got to do that. Okay, so let's find the midpoint. Midpoint, midpoint, midpoint. All right, so for the midpoint, we're going to use that midpoint formula, right? So the midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. And what are we doing? A and C. So A, we'll say A is 0, 6, and C is 4, 0, right? So this is my x1, y1, x2, y2. Okay, then we're just going to substitute the values in. So we end up with the midpoint being x1 is 0 plus x2 is 4 divided by 2. y1 is 6 plus y2 is 0 divided by 2. All right. And what does that end up being? 4 divided by, that 0 plus 4 is just 4. And 6 plus 0 is 6. So 4 divided by 2 is 2. And 6 divided by 2 is 3. Okay. So that's what our midpoint is, which means that's what D is. D is 2, 3. All right. Perfect. So now what we need to do is we need to find the area of this triangle. Now, I don't know, when you do the area at the base and the height, it needs to be at a 90-degree angle. I don't know if this is a 90-degree angle. But what I do know is that for this small triangle, I can do the base here, right? And then I can do the height here. And if I go straight there to that point, I know that this is a 90-degree. So this is going to be my base, and that's going to be my height. Okay? So I'm going to find the area of triangle, what triangle am I finding? ADB. Okay, and that is equal to 1/2 base times height. Base times height. Okay, where my base, this is my base, and that is 6. And my height is here at 0, and it goes all the way to this x part, which is 2. So this is, the height is 2, 1, 2, okay? And then I'm going to substitute those values in. So I get the area of triangle ADB equals 1/2 the base, which is 6, times the height, which is 2. Then I'm just going to simplify, right? So we got the area of triangle ADB is equal to 1/2. 6 times 2 is 12. And then finally, the area of triangle ADB is equal to 1/2 of 12 would be 6. Okay, perfect. So, let me show you how we're going to do this. So let's say we take this right here. Okay, so I'm going to show you how to write a proof. Because we need to write this. We need to write the area of triangle ABD is 1/2 the area of triangle ABC. Okay, so we're going to go with this one. Okay, so we want to come up with this. Area of triangle ADB equals 1/2 area of triangle ABC. Okay? All right. Okay, so we're going to start here, and I'm just going to write this statement here. And watch how I get this. Okay, so I'm going to write this. Area of triangle ABC is equal to 12. So I'm going to basically build this statement. So I found this, okay? Now what I need is I have area of angle of triangle ABC, right? But I need 1/2 area of triangle ABC for this proof. So what I'm going to do is I'm going to do the multiplication property of equality, and watch. I'm going to multiply, ABC. I'm going to multiply both sides of this equation by 1/2, because that's the multiplication property of equality. Okay? Then I simplify. I'm left with 1/2 area of triangle ABC, which is what I need. That's what I need right there. Now I just need this to equal the area of triangle ADB. Well, 1/2 of 12 is 6, right? But then guess what? What equals 6? Area of triangle ADB. So I'm going to take this and I'm going to substitute it in there for 6. So I'm going to say, I'll write this, okay? Area of triangle ADB equals 6. And actually, I think what I'm going to do is, instead of substituting that into that, I need this to say, look here, I need it to start here. And it starts here, right? And then I have 6. And then I need that to equal this here. But 6 equals this. So if I take this statement here, and this statement equals 6, and then I substitute it in there, I'm going to have exactly what I want. Area of triangle ADB equals 1/2 area of triangle ABC. So that would be, I'm going to go ahead and go that, and I think this is pretty much the transitive property of equality. So area of triangle ADB equals 1/2 area of triangle ABC by the transitive property of equality. So that's how we can get that statement. Okay, you kind of like build a proof there. So you see, that's what we proved. The area of the triangle, this small triangle, is 1/2 the area of the whole triangle. So the area of the small triangle is 1/2 the area of the big triangle. All right, that was our first coordinate proof, or our second one. Good job. Okay, we'll see you in a little bit for example 3.